Hello forensic scientists and welcome to Forensic Glass Analysis. In this video, we will be addressed 5 different questions and then at the end we will do the demonstration on how to analyze glass analysis. So, the first question that we'll address is glass a solid or a liquid? What state is glass? What it is made of? What it is composition? And the third thing is, well, as the question, we will look at the different types of glass that exist and also examine the 2 different ways a sample can be matched to a crime scene along with discussing the physical properties of the glass. The 5th topic is looking at the fracture pattern. Can we determine from which direction a bullet or a projectile come from? Then look at the stress or cracks, and we will see if we can determine from those cracks which projectile or direction of the projectile come from. From there, we will help us to rebuild the crime scene. So let's get started.
Is glass a solid or a liquid? There has been some misconception in the past. People go to the outdoor museums or old storefronts and notice something unusual. In the old windows, the bottom of the glass pane is thicker than the top. Because of this, people think glass must move over time, pulled by gravity. While gravity does have an effect, and it would take millions of years to notice any real change. So why is glass thicker at the bottom than at the top? It's because of how it was made. Old glass making method. In the past, a method called the crown glass method was used. A blowpipe was used to inflate molten glass and it was spun into shape. This created a large globe, like a huge bubble. After cooling, the glass was cut into squares. As the glass got closer to the center, it became thicker. Builders placed the thicker end at the bottom to make the window more stable. So the thickness difference is not from the gravity pulling in the glass down. It's simply due to how the glass was made.
Conclusion: state of glass. Because of this, we do not classify glass as a solid. It is also not a crystal. In crystals, atoms align perfectly in a uniform structure. In glass, atoms do not align perfectly, so we can classify glass as an amorphous solid, a solid without a clear internal structure. Composition of glass. What is typical glass made of? There are 3 main components. It can include more, but generally about 75% is silica or sand or silicon dioxide. Lime or calcium oxide is also added. This helps keep the glass from dissolving in water. Sodium oxide is added to lower the melting point. Glass must be heated to very high temperature to melt and form. Sodium oxide reduces the temperature, making the process easier. And it's used in the sides of car windows and in the rear of cars. It's stronger than normal glass because of the rapid heating and cooling process of the glass surface. It's relatively safe in the case of accident because when it breaks into very small fragments rather than big sharp shards, like what would happen when you throw a baseball through a house window. Instead, the pieces break into a very small pieces.
Therefore, it's less likely to impale a person upon impact. Cookware also uses this type of glass, like Pyrex, which is tempered glass. We also have laminated glass. This is used in the front window of cars, the windshields, It's basically a sheet of plastic sandwiched between two sheets of glass. So the glass is pressed into the plastic because of this. When it breaks, it doesn't really shatter. It cracks but stays mostly in place, like what you've been seeing in movie. This makes it even safer than tempered glass. Then you have glass bottles in house windows. They are made of soda lime glass. It's made from the same basic composition, but the heating process is simpler and faster. When it breaks, the pieces break into relatively large shards. That's why when you push on a house windows and it breaks, it forms very large pieces.
This is the easiest and cheapest way to produce glass, which is why it's commonly used in construction. Then you have crystal glass, like what you find in champagne glasses or fine glassware in fancy restaurants. This is not typical soda lime glass. It can contain about 30 to 40% barium oxide or zinc oxide instead of just silicon dioxide. Because of this composition, crystal glass has a high refractive index, which makes it look glittery and sparkly. That's why it appears more elegant and beautiful. For modern devices like phones, iPads, and tablets, the screens are made of aluminum silicate glass. These screens are mostly silicon dioxide, but also contain aluminum. With the right heating, melting, and cooling process, these screens become strong, thin, durable, and resistant to scratches. Now, we move into analyzing fractures, looking at cracks in glass and how glass breaks.
Analyzing the cracks or the glass fracture. When a glass is hitting by a projectile like a bullet or a stone, it creates cracks that spread outward. These cracks are called fractures. There are two main types of the cracks, which is the radial fracture cracks
Crucial to the
that
case is
spread
the
outward
testimony of the
from the
witness.
point of
This
impact,
individual personally
and
observed
eccentric
the
fracture
perpetrators
cracks
entering the
that form
victim's residence.
in a circular
This witness
pattern
provides
around
a
the impact.
detailed statement regarding what
The
was seen,
formation,
which
radial
served as
fracture
vital
come
evidence.
first,
This
while
account
the
will
eccentric
later be
fracture
formally
form
presented
afterward.
and stormed under oath during
The
the court
direction of
proceedings.
impact. By studying this fracture, forensic scientists can determine the direction of
Following the
impact.
investigation, authorities have
example,
located
if
and
a projectile
identified the
moves
person
from the
suspected
left to
of
right
committing the crime.
and hits the glass,
He is invited to cooperate and
the
undergo
cracks form
necessary
at the point
laboratory
of impact.
examinations.
the
The
backside
scientific
or exit
tests are
side of the
conducted
glass is
to
usually
compare
more
evidence
damaged
and
or blown
determine
out.
if there is a
The
match
observation,
confirming
the backside
his
of a
involvement
radial
in
cracks
the
is wider.
incident.
It looked like it broke outward. Then the concentric cracks start on the same side as the force or the front. How to identify the radial and concentric? First is check the missing glass. Missing on the front impact side, that is concentric fracture, while missing on the back side, that is radial fracture. Look at the stress marks or the under the microscope. The radial fracture form right angle 90 degree on the reverse side. The important rule: the radial fracture right angle on the reverse side. The front and back. The front side where the projectile came from, while the back side, it is the opposite side or the exit side. The final tip: if the right angle is on the back side, that is a radial fracture, and if the right angle is on the front side, that is concentric fracture.
The second and the third phases shift toward the identification and comparison of the glass types through the refractive index Ri and UV fluorescence. Using the immersion method, fragments are submerged in a virus liquid to find their match point. When the glass becomes invisible, its Ri is equal to the liquid, providing a numerical fingerprint that can link a suspect to a scene.
Analyzing glass fracture. In this part, we will analyze glass fractures to help reconstruct a crime scene. First, we will determine the direction of the bullet from the observing that cracks. It tells us where the projectile came from, the left or the right, inside or outside. Next, we will identify the sequence of the impacts. When there are multiple bullet holes, fractures from a later shoot will stop when they meet earlier cracks. So, the cracks that continues is from the first shoot, while the one that stopped is from the second. For the demonstration, there are more useful than concentric fracture. Using a discentric microscope, we look for 90 degrees stress marks. According to the rule, radial fractures from right angles on the reverse side of the force. If the 90-degree angles appear on the side, that is the opposite side of the impact. So, if the stress marks are on the top, the bullet came from the bottom and the vice versa. In the example, the bullet came from the side of the G. Another way to confirm is by observing the glass break pattern. The glass tends to break outward on the reverse side, meaning the exit side shows more damage. With this observation, we can determine the bullet direction and reconstruct the event.